There we go. So tether lines are used to study an inflatable snowman. Suppose you know the height at which the tether lines are attached to the snowman and how far away you want to anchor the tether in the ground. You can use the converse of the Pythagorean theorem to adjust the lengths of the tethers to keep the snowman perpendicular to the ground. So if you want your snowman to be perpendicular and you know your two different lengths, you can find that other length of that triangle. Okay, so we can find that other length of that triangle. So before we start with the Pythagorean theorem, I do want to label different parts of a right triangle. So within a right triangle, you should have a 90-degree angle. Okay, so we have a 90-degree angle. Opposite that 90-degree angle or across from, okay, so to the other side, that is called your hypotenuse. Okay, so that is called your hypotenuse. The other two sides are what make up your 90-degree angle. We call those legs. Okay, so those two segments there that make up that 90-degree angle we call legs. Okay, one more example here. If I label this side as this angle as my 90-degree angle, label the sides of that triangle. Okay, so label the sides of that triangle. Find the hypotenuse, label your other two sides. So you do need to know how to identify the hypotenuse of a right triangle in order to use the Pythagorean theorem. So your hypotenuse should have been over here. Okay, then the other two sides should be labeled as legs. Okay, so definition of a right triangle. Okay, it is a triangle with exactly one right angle. Okay, so you have one right angle within your triangle. It is considered a right triangle. So then, the Pythagorean theorem, I am going to highlight that if I can find a good highlighter here. Okay, so we are using the Pythagorean theorem today. The definition, it has to be in a right triangle. So you must have a right triangle in order to use this. Okay, in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So you can square both of your legs. Okay, here I labeled the legs. Square both of your legs, add them together, and it should be equal to your hypotenuse squared. Okay, so that's where we have a squared plus b squared equals c squared. Okay, where c is always your hypotenuse. Okay, so that c value should always be your hypotenuse, which is your longest side. Okay, it should be your longest side. Okay, or if you want to start with your hypotenuse, you can. So c squared will also equal a squared plus b squared. Okay, and you can see them labeled over here in this triangle. So we have c on this side, that is the longest side. It is across from that 90-degree angle, so it is the hypotenuse. A and B, you can interchange those, so it doesn't matter which leg you start with for A and B there. So we are going to do an example, but do you guys have any questions before I start? All right, so then letter A. First thing I do is locate my hypotenuse, which is my C value. Okay, so here I have my 90-degree angle. Okay, the side across from that 90-degree angle is your hypotenuse. So that is your C value in our Pythagorean theorem. The other two sides have to be A and B, and again, those can be interchanged. So I'm just going to label 6 as A and 15 as B. If you labeled 15 as A and 6 as B, that's fine too. So from here, all I have to do is plug this into my Pythagorean theorem. So we would end up with 6 squared plus 15 squared is equal to x squared. Next, I would square each of my terms here. So 6 squared is 36. 15 squared is 225. That's equal to x squared. Okay, next I add my two numbers together. That's 261 is equal to x squared. Now to get x by itself, I need to take the square root of both sides. Okay, so taking the square root of both sides, and keeping in mind when I do that step, you actually end up with x is equal to plus or minus that square root. But since we're looking at the side length of a triangle, your side length can't be negative. Okay, so when using the Pythagorean theorem, it's always going to be positive. Okay, so we would have x is equal to the square root of 261. Now, we simplified yesterday, right? We practiced simplifying. Okay, so what I would do, since I don't know all the factors of 261, I would take my calculator, I would divide it by 4, see if that works. Divide it by 9, 16, and so on. So when I did that, this does split into the square root of 9 and the square root of 29. Okay, so 261 can divide by 9 there. So I can take the square root of 9. It is 3. And I'll leave the square root of 29 as it is. Okay, questions on how I did A? All right, I want you guys to do B. Make sure you label your hypotenuse first. All right, so I did just plug in my values to the Pythagorean theorem here. I did notice some of you wrote x squared is equal to 11 squared minus 9 squared. That's fine. Okay, that works too. But if I just plug it into my original Pythagorean theorem here, I'll get that same answer. So I have x squared plus 81 is equal to 121. I want to subtract 81 from both sides of my equation so that I get x by itself. So I have x squared is equal to 40. And again, I want to take the square root of both sides. Okay, keeping in mind I do get this plus and minus value when I do that, but since I'm talking about the side length of a triangle, it will just be a positive. And then this square root of 40 does simplify, so I can split this into the square root of 4 times the square root of 10. Okay, so that I end up with x is equal to 2 times the square root of 10. Questions? Are we good? Yeah? Okay. All right, then on the back, we have some Pythagorean triples. Now, Pythagorean triples are 3 non-zero whole numbers such that a squared plus b squared is equal to c squared. So you end up getting a whole number when you take that square root. Okay, on the front, we didn't get perfect squares, right? We had to simplify and leave it in a radical. For Pythagorean triples, you will have a perfect square. So some examples of those are 3, 4, and 5 for the side lengths of your triangle, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. Now there's more than just those 4. Okay, there's more if I combine more numbers off to the side there. But we can create more Pythagorean triples with just these 4 examples. Now to do that, I can multiply a number into all 3 of those numbers. So 3, 4, and 5, if I multiply each of those numbers by 2, I would get 6, 8, and 10. That's also a Pythagorean triple. Okay, I could also multiply 3 into all 3 of those numbers. So if I multiply 3 by 3, I get 9. 4 times 3 is 12. And 5 times 3 is 15. Okay, that's also a Pythagorean triple. So you can take each of these numbers and multiply it by any given number, and you'll get another Pythagorean triple. So I can take 3 and multiply it by any number, 4 multiply it by the same number as 3, and 5 multiply it by that same number and get another Pythagorean triple. Okay, so there's an infinite amount that you could get. Okay, same thing is true for 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. Now in each of these Pythagorean triples, it is good to note that your largest number is your longest side. Okay, your largest number is your longest side, meaning it is your hypotenuse or C value. Okay, so here 13 would be C, 17 would be C, and 25 would be C. Okay, so that longest side is your largest number. So we're going to fill in the rest of this chart here. I'm just going to do the same thing I did with my first Pythagorean triple. So I'm going to take each of my numbers, multiply by 2 to get this second row. So we have 10, 24, and 26. Then in that third row, we'll multiply that top row by 3. So 5 times 3 is 15. 12 times 3 is 36. And 13 times 3 is 39. So again, the rule at the bottom, I can make any Pythagorean triple by multiplying those 3 numbers by the same value. Okay, with 8, 15, and 17, we get 16, 30, and 34. Multiplying by 3, I get 24, 45, and 51. Okay, then our rule is 8x, 15x, and 17x. Okay, our last Pythagorean triple, taking 7, 24, 25, multiply each by 2. So we have 14, 48, and 50. Multiplying each by 3 for that third row. So 21, 72, and 75. And then writing the rule for that triple, which is 7x, 24x, and 25x. Questions on triples? Then we're going to use our triples to answer these two questions here. Okay, so when we're using our triples, I'm going to look at the two sides that I'm given. So in this case, I have 48 and 20. I want to see what I can divide into both of those numbers. Go ahead.
Who's just for 90s? Okay, thank you. Solomon, are you dressed for the 90s?
I am.
What class are you an advisor of?
Huh?
What class are you an advisor of?
Freshman.
Okay.
All right, so here I have a 48 and a 20. I want to see what number divides into both of those. Okay, so both of those numbers I can divide by 4. Okay, so if I divide both of those numbers by 4, 48 divided by 4 is 12. 20 divided by 4 is 5. I'm going to look at my common Pythagorean triples up at the top, and I want to find where my two shorter sides are 5 and 12. Okay, so my two shorter sides right here are 5 and 12, meaning that third side would have to be 13, right? Now, that's after I divided by 4. What do I have to do to that 13 to get x then? Multiply it by 4. Okay, so I have to multiply that 4 back in to get x. Okay, and when I do that, I get x is equal to 52. Okay, and then the Pythagorean triple that I used, so stating the triple, that would be 5, 12, and 13. That's the Pythagorean triple that I used. Okay, we're going to do the same thing in letter D. So this time my longest side is 50, and one of my shorter sides is 14. I want to pick a number that divides into both of those. Okay, so both of those do divide by 2. Okay, so when I divide 50 by 2, I get 25. 14 by 2 is 7. So looking for that largest side is 25 and one of the shorter sides is 7. That would be this triple right here. Okay, meaning my other shorter side is 24. And again, I would have to multiply that 2 back in to get my x value, which is 48. I know it's sideways, sorry. And then the triple that I used was 7, 24, 25. Okay, questions on your triples? Okay, then looking at letter E. So Lucy is locked out of the house. The only open window is on the second floor, which is 12 feet above the ground. Okay, so we have 12 feet above the ground. To avoid some bushes, she places a ladder 5 feet from the house. And we want to figure out if a ladder that is 15 feet will be long enough to get into the window. So we're going to draw a sketch of what's happening. So I have a window. It doesn't have to be beautiful. I have a window. I know it's on the second floor. Okay, so I'm just going to draw a line straight down. Okay, that window I underlined is 12 feet above the ground. Okay, so 12 feet above the ground. We'll go on that vertical line there, if this is the ground. Okay, she's going to place a ladder 5 feet from the house to avoid a bush. Okay, and we want it to lean into the window. So here's my ladder. Now that ladder, the base of it has to be 5 feet from the house. And we want to know if a 15-foot ladder will be long enough. So what I'm going to do is label that ladder as X, because I'm going to see what that shortest length has to be in order to get to the window. So to figure that out, we're going to use the Pythagorean theorem. The house and the ground make this 90-degree angle here, meaning that X value is your hypotenuse or C value in the Pythagorean theorem. Okay, so A and B are 5 and 12. So we have 5 squared plus 12 squared is equal to X squared, which is 25 plus 144. Okay, add those together, I get 169. It's equal to X squared. Take the square root of both sides. Again, keeping in mind you get a plus and minus. I'm going to remind you that every time. Okay, but we're talking about a length, so it has to be positive. So it has to be at least 13 feet. Is our ladder long enough? Yes. Okay, so that 15-foot ladder will be long enough. Questions on how I did letter E? All right, then I want you guys to try letter F. The picture is drawn for you. You just have to label it. Okay, figure it out together. It's close.
This is the decimal I got. I just rounded it.
Oh. Oh, because that's why. 20 is your hypotenuse. So you have to subtract instead of add.
Oh, got it.
Make sure you look at that 1/4 of the ladder's total length to find that base. 1/4 of the ladder's total length to find how far away it has to be from that wall. Yes. Yes. You done?
Yeah.
All right, so I'm going to go over F really quick so that everybody can start on their assignment. So main thing here, you had to look at that at least 1/4 of the ladder's total length. So the total length was 20. So 1/4 of 20 is 5. Okay, 1/4 of 20 is 5. So that's how far it has to be placed from the wall. So setting up my equation, this 20 feet is your C value. It is your hypotenuse. So that's what needs to be plugged in here. 5 can either be plugged in for A or B. It doesn't matter. So I would have 5 squared plus x squared is equal to 20 squared. Okay, that's 25 plus x squared is equal to 400. Subtract 25 from both sides of your equation. X squared is equal to 375. Again, take the square root of both sides. When you do that, you get that plus or minus, talking about side length, so it has to be positive. And you can simplify the square root of 375. Okay, that simplified is 5 times the square root of 15. If you wrote it as a decimal, it was 19.4 feet. Okay, any questions on F?